Hello and welcome to the Sound on Sound People and Music Industry podcast with me, Sam Inglis. In this episode, I'm delighted to be joined by Colin McDowell of McDSP. Welcome, Colin.
Thanks for having me, Sam.
McDSP is a name that, if you're a Pro Tools user especially, or if any kind of computer user in the music business, you'll have known about for a long time, because McDSP were one of the first developers of third-party plugins for Pro Tools TDM that I can remember back in the day. How did you get into that business in the first place?
Well, like many people who try to make audio products for a living, I'm a terrible musician / audio person. So I always liked music. I always liked engineering. I thought any way I could figure out to combine them would be great. And so I, at some point, did land a job at DigiDesign. And I used to work on plugins. And then at some point, I just wanted to do it on my own. How shall I say it? I'm not the best keyboard or guitar player, but if you want a plugin that makes a certain sound, apparently I have skills to do that. I don't have any other skills, but those are the skills I have.
But I guess back in the day, there wasn't much training available for people who wanted to get into plugin design. How did you learn about it?
So my undergraduate degree is in, I'm a double E, electrical engineering, with my specialty is in signal processing. So I've done a lot of signal processing prior even to doing it for the music industry. So from Pro Tools, which had its, one of the first sort of plug-in platforms, I learned about that there's a specialized software component you can build. There's a specialized, algorithm to manipulate a signal. I'm like, that's me. That's what I can do. This is great. So as I got that job at DigiDesign and I got to work in the plugins group, I sort of got to see how the plugins are put together. And then I just thought, boy, this would be a lot of fun to do it on your own and come up with your own algorithms and things like that. And eventually I got McDSP started in 1998 and just have been doing it ever since.
So in those early days, of course, you were coding for the DSP chips on TDM cards. And then at some point you've moved over to also writing native plugins. How different are the two from your perspective?
Firstly, I think any algorithm development should be platform agnostic. You should just be coming up with something that you think is fundamentally sounds good and is not overly complicated. I think it's interesting to me, not just in the audio signal processing realm, but in signal processing in general. Most of the best algorithms can really be broken down into very simple components. Maybe there's some math in there somewhere, but ideally it's not convoluted or overly complicated. So that's to start. Then your question, is it like an embedded DSP system or a native system? Those, if you've managed to come up with an algorithm that is, again, straightforward, is broken down into, easy to understand components, the creation of the algorithm, either it's an embedded DSP or a native processor, the workload, I think, is almost equivalent. If it becomes complicated, then you need to back up and look at your algorithm and go, what was I thinking when I said, hey, 6 feedback loops into this thing, and then we'll just randomly take an average and no, stop, time out, cut back. So I think they're almost equal. Embedded systems like TDM or native, the only thing that I think it's different is that in embedded systems, you have to define all your memory space, which is just it's like cleaning your room or your studio, right? If you do it enough, you get really good at it. You know where everything is. You don't lose half your stuff every time you clean up. So managing your memory in an embedded system is kind of like keeping your studio clean. But then conversely, in native, you don't have to do that. So then sometimes you get sloppy and do something really dumb like, hey, I thought I put all my mic cables in a piggy bank on the top drawer in the back room. Isn't that smart? No, we need all the mic cables now. Oh, well, I'll be back. I crammed them all to this piggy bank. I'll have to break it open with this hammer. These are the jokes, people.
So this process of coming up with an algorithm for a plugin, is that something you do almost on paper or in your head, or is that something do you have tools that help you do that?
Well, because I've been doing it for a long time, my wife would say it's all in his head because that's all he talks about. I think a lot of the times it comes down to, yes, in my head or just on paper. A lot of time on paper, it's like, oh, I wrote down some formulas. Usually it's like some flow diagram, like, oh, the signal is coming in here. It has this problem, or I want to get this out of it or make it do the following. Then I might say, well, if I had one of these and one of these, and the initial flow diagrams, they're like, wow, it's really complicated. Surely there's got to be a better way to do this thing I'm looking at. And then we sort of break it down. And when there's like a decent flow diagram, then we use tools like MATLAB. I'm mostly a MATLAB fan. I just like MATLAB. And we use that to maybe simulate the flow diagram. I can put test signals into it. take test signals out and kind of see, yes, that's what I thought it would do, or, oh, that's terrible. Well, I'm glad I didn't waste a bunch of weeks making a plugin out of that. But then at some point, I go, hey, that's pretty good. And then we take it and start building up a plugin in the UI. And when I say building up a user interface, I mean just like something that looks like just totally awful. Hey, look, a green box with just like, knobs from another plugin on it. It's like every prototype plugin we make is like, oh, look, I took the background of filter bank with the knobs from the 6060 input module and I'm just grabbing something just to piece it together and go. But then we just play with it. At the very end, we'll do the user interface.
I mean, talking about user interface there, how important is the user interface, do you think, in the usability of a plugin?
I think it's as important as the sound. I mean, if the plugin sounds great, but it's difficult to use, no one's going to know because they won't know how to use it. Conversely, if the user interface is great, but the plugin sounds like crap, no one's going to like it either. You just have to have both, which I think is good. It's good because it makes people, these days at least, think about what am I making, how will the customer use it, what are the important features I want to make sure are readily accessible or discoverable, and some of the more tweaky things, yeah, if it's not quite right in your face, that's okay, but the more experienced user will discover them and then be able to exploit them relatively quickly.
So is that something, when you're coming up with the initial algorithm, you already have in mind what controls you want to present to the user?
I do. At least these days I do. Generally, as I come up with the algorithm, I already have the controls in mind because the algorithm is supposed to do X, and to accomplish X, I need a threshold and sensitivity and something else. And I'll have those in mind as the controls that's going to be. And so it all comes together. And that's something else you mentioned about this, the controls, is sometimes you make an algorithm, you go, this is the algorithm, and this is how it's going to sound. Okay, it sounds how I'd like. Great, here's the interface, great. And then someone goes, oh, I'd really like to adjust this. What? Yeah, I'd always like to adjust this part. Well, why? Because when I do this, this, and this, P.S., I'm like, famous mix engineer, film, whatever, TV person. Oh, so you know what you're talking about, and that's a common usage point. I got you. I'll add that control. Can do. Then you change it. So sometimes there are things like that. But it's good to have a control set in mind as you go forward with the algorithm.
And I'm interested in your take on vintage emulation, because a lot of the McDSP plugins are capable of recreating the sound of some vintage units, but you never seem to package them in kind of photorealistic vintage GUIs or anything like that.
It's true. I mean, I think, like with our most recent release, we definitely have tried to make some user interfaces that look kind of real, but they have lots of, functionality you expect in software. And that's, I think, kind of we're trying to find as our balance point. But as far as like emulating vintage gear, I mean, don't get me wrong. I've spent a lot of time looking at a lot of, other, pieces of equipment that people say, oh, this is the holy grail of EQ or compression. But I'm not sitting there going, yeah, they use the 1024 586 diode with the resistor bridge, blah, blah, blah. I'm like, I don't care. I just want to know, how does it sound? Why does it sound good? What do the shapes of curves and things look like? And then just kind of come up with my own way of doing it, which I think is way more fun. I don't know how to say it. And I think then that's, so I guess, I think if people want to emulate vintage stuff, I think it's great. If they want to make something new, I think it's great. I just like making things that sound good. So I don't really care if it was made yesterday or, 60 years ago. If it has some sound, people, oh, I love the sound of that. I just want to know why. Why does it have a good sound? I don't care, is it made out of tubes or solid state or I don't know, it's a rat running around in a cage powering the thing. I don't care. I just want to know, why does this sound good? Why does it work for people who make this kind of music or whatever? And I just want to know that because I think that's fascinating. I just want the sound. If I get the sound, great. It can look like whatever you want.
So in as much as you refer to this vintage gear, it's kind of a black box for you. It's like, as long as you get the transfer function in and out, then you don't really care what's going on inside.
That's totally it. And in my prior life, career, whatever, yes, black box design is exactly what I specialized in. I didn't really care what was inside of it. And sometimes I didn't know. They just said, yep, just, make it do what that does. Okay, that's kind of creepy, but I'll do it. And so that's what I would do.
So how do you think plugins have improved since those early days? I mean, we're talking about well over 20 years of plugin development here. How have they got better in that time?
I think they've gotten better because the customer's expectation has the bar has been raised. I think that a lot of people are good at making good quality audio productions, and so they're paying attention to like, oh, what does this EQ or compressor sound like? And they really actually kind of know, at least to my mind. And so I think that the game has been upped for everybody, which I think is really good. It just means better products come out, and that's fine. Computers have gotten a lot faster, so I think people are more, I don't want to say it. Earlier in this podcast, I mentioned don't make things overly complicated, but now you can make some pretty complicated algorithms. So I think that some people are exploring more, I won't say sophisticated, but more sophisticated ways of coming up with a way to process sound that's very useful to the end user. And I think that's exciting. I think there's enough people doing it now where it's like, oh, like that's like a thing people do, as opposed to like, as you mentioned when McDSP first started, I'd spend half the time explaining, this is a plugin. It's a separate piece of software that did not come with your DAW. You have to buy it from us. No, we're not DigiDesign or Apple or Steinberg or whatever. Oh, yes, McDSP. Yes, that's us. Yes, back to the point. Okay, so we make a plugin. It's a separate piece of software you have to buy. So that's all done. People go, oh, yeah, plugin, I get it. Oh, great. Well, fine. So, that they, just like there was an acceptance transition of doing audio production in a computer, there's also I understand what a plugin is and why I might want some extra ones that did not come with my DAW that might do some of the same things but differently or have a different sound. That in that way, it's a very mature market, so plugins can be better.
So you were talking about how processor power now means we can have more complicated plugins for good or for bad. One buzz phrase that crops up a lot in terms of that kind of plugin design is machine learning, which a lot of companies claim to be using. Is that something you've explored at all?
Yes, we have. I think the only thing that end users see these days is we have a module in the 6060 called Shine, which is just like a high shelf, but like it's a linear phase, high shelf, nice sounding EQ. Actually, my daughter, who was in college, she's studying engineering like her dad, and she said, I want to do some AI, Dad. I said, oh, you do, huh? Well, here you go. Train this algorithm to learn what this kind of EQ shape would be, and just keep training it until you get something that sounds good. And she's like, yeah, I got this. And so like at the end of the summer, she's like, it's like months later, she's like, Dad, why is the computer so stupid? I'm like, it's called artificial intelligence, kiddo. She's like, yeah, okay, I get that. Yeah, okay, that makes a lot of sense to me now. Understand, got it. Anyway, SHINE also stands for Secretly Helena's Intelligently Networked Equalizer, SHINE. So we have explored stuff with it, but mostly it's to just see if we can come up with like different prototypes of things and then just look at it and see what the end result might be and if that's something useful to us. And that's about it. I think that the use of AI is great. It's very interesting for like, trying to train the computer to like, I don't know, master all your mixes the same way or come up with an intelligent EQ curve to suit a certain application. I think the only thing about AI that I don't like is it usually to have a system that's trainable and smart enough, in quotes, to do those things, it becomes a pretty complicated system. And if at some point in the training process it's trained incorrectly, it's really hard to train something out of an AI. I mean, you can. It's just kind of a weird thing. It's like, teaching someone how to ice skate. If you only teach them how to skate backwards, they'll never skate forwards.
Yeah, and one of the classic problems with AI is that thing called the black box problem, where you can train an AI to do something, but then you've actually got no idea how it's doing it. So if you want to modify its behavior, what do you do?
That is correct. That is, in fact, a huge conundrum, right? You can train your Google, whatever the heck. Oh, it's Tuesday. Sam, don't you need to buy some new microphone stands? The short kind, because that's what you need, right? Oh, how does it know? And then you go do it. But, how does it know? Yeah, nobody knows. There's some parameterization there and stuff, but yeah, it's kind of like, I know. Yes, you are correct, sir.
So you have been exploring a different technology, though, because back in 2019, you introduced a thing called the APB, which stands for Analog Plugin Box. And this is, for anyone who's not seen it, it's actually a digitally controlled analog device. It looks to your computer like a DSP plugin board that you load plugins into Pro Tools or Logic or whatever. But in fact, the processing is taking place in the analog domain. It's super clever, sounds amazing. How did you come up with that idea?
Well, like most people with obsessive compulsive disorder, if you think about something long enough, at some point you go, wait, we could do this. Really? You think? What do you know? what we make on our talked about the algorithm. All our plugins have literally the piece of code is called a brain, and the brain is like that's what the algorithm does. And we made it so that we could have the brain can sit in an AU or a VST3 or an AAX plugin embedded or native, blah blah blah. But at some point, someone went, maybe his name was Colin, I'm not sure. Wait a minute, this is like a self-contained piece of code that has inputs and outputs and controls. I don't even know what's inside in theory. So couldn't I just take the guts out of what's in the brain and put it like back into analog? I mean, could that work? That would be possibly really cool and really expensive, but why not? So, yeah, we tried some of that, and some of it just didn't work. I was like, oh, okay, that doesn't work. That doesn't quite translate. But other parts really did. And then we're like, well, wait, because if imagine like that brain piece of code is like the same thing. We're just talking to the same thing. We just happen to, the guts of the brain are just in an analog board somewhere, maybe a little more complicated than that, sample accurate synchronization and automatable and configurable and yada, yada, yada. But yeah, I guess that you mentioned vintage gear. People have this religion about, vintage versus new, digital versus analog. And I sort of tried to state, I don't really care what it is. I just want something that sounds good. And wouldn't it be interesting if you took here's a compressor we've made before, but what if we took it and put it in the analog domain? I will choose some of the most expensive parts we can find and just put together a signal path and go, how would that sound? And at some point we're like, wow, that sounds really good. To the point where even take used to have these silver APBs that not painted or anything, and they're hot as heck. And we take it and people go, hey, does this sound good to you? Oh, it sounds really good. Can I keep it? No, 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 no. Just a prototype. Nothing to hear. Sign this NDA. Thanks for coming. See you later. And so, yeah, very long-windedly, it just seemed like an interesting project to explore. It turned out really good. I'm very appreciative of the people who've taken the time to check it out because I do, my completely biased opinion, think it's really cool.
So have you worked on analog electronics before, or was this an entirely new development for you?
The most analog electronics I've ever done was, still when I was in college, which was, okay, I'll admit it, back in the late 80s, early 90s, before the internet and when dinosaurs roamed the earth. Yeah. But I like that stuff. My other hobby, some behind me, not in the video, but I do have a lot of analog synthesizers. I grew up in Buffalo, New York. So my sort of knowledge of what is a good sounding analog device really sort of originated from analog synths. And why an analog synth sometimes is like, wow. And a digital synth is kind of like, not quite what I want, but it's cool. What's different about it? Gee. But we did hire a few additional engineers who had a lot of hardware experience. And they've done a really good job. And they're kind of like me, when I told them the project is basically we're going to make an analog device. It's configurable, controlled in software, and there's basically no budget. Just make it as cool as possible. Really? There's no I have to skimp on this or that? No, because if we skimp on anything, they're going to just crucify us on the internet. So you just, can we use 32-bit converters? Sure can. Can we use gold-plated Wheeler cap, blah, blah, blah? I'm like, yeah, I don't care. I mean, whatever, dude. I just so that also was fun for them because it was I don't know. I just trying to make the projects fun here sometimes.
I guess when you're developing digital plugins, one difference is you don't have any issue with tolerances, component tolerances, for example, in digital. In analog, that must be quite a major concern, I guess.
It is. I think that we seem to have come up with some ways to mitigate that. Actually, interesting about the tolerances. So the APB itself is self-tuning. So you turn it on, it has a bunch of calibration points all across its analog board and elsewhere, and it's just listening to itself all the time. So if it thinks it needs to adjust itself, it just does it. There's even when we manufacture them, like they're manufactured right here in Northern California. It was funny because the manufacturer's like, okay, we see what it is. It looks kind of complicated. How do we test it? Oh, we have this automated application. It'll test all the channels for you. And they're like, oh, really? Yeah, you just click run test and it'll do it. And then at the end, it'll tell you if any of the channels have some tolerance issue and you have to fuss with that. Yes, to answer your question, yeah, tolerance stuff is difficult. But I think we've chosen parts that are very reliable. But the APB units also are somewhat self-tuning. And it's worked out pretty good.
So it's analog, but it's not your granddad's analog.
No, I mean, some people say, "Hey, there are tubes in there." I'm like, no, there are no tubes in an APB because that would be breakable, or get really, really, really hot. Like 16 channels of that. I think there's like 124 op amps, like in an APB 16, like something like almost dumb, where you're like, okay, well, that's a lot of heat. Yeah, it is. Well, how do you dissipate that? Well, just happen to have a dad who's into this kind of stuff, and he has a friend who's into physics, and he suggested, emissivity. You can look that up later and just understand what that is and paint the inside a dark color and make sure it has lots of surface area, make it a material, aluminum, that will, absorb and dissipate the heat more quickly. It's fun.
But talking of tubes, it doesn't have tubes in, but some of the plugins you've made for APB do emulate tubes. What's
That's right.
what's the process of emulating analog using analog? How does that work? How is it different from doing it digitally?
It's a new world, I'll tell you that. Sometimes it goes well, and sometimes you'll have the occasional, like, oh, sorry, I have to rip my headphones off because something didn't feedback the way I thought it was supposed to. So the idea is that when we have, again, that brain that can do a certain sound, and we said, hey, brain, we're going to make you analog now. Brain says, fine. And then we ask the brain, please, there's this model that we can put into the brain. This you're going to be like a tube-based compressor. And the brain's like, I got you. And then it'll configure the analog system to do that in as much as it can. And then we're like, okay, cool. There are, it's not software. We don't have like a blank slate, but we do have enough configurability in the analog chain that we can come up with a lot of sounds. And so we just sort of know what those ranges are, and we just try to massage them into, yep, this is about the tube model, or this is kind of a new tube model because we had to modify this or that. We put it all together, and what you get is what you see with the APB plugins we keep coming out with for the APB 16 and APB 8.
So when you have, say, a compressor model, as it were, running on the APB, is the whole thing running in the analog domain, or is it just the gain reduction element that's analog and the side chain detection circuit is digital?
Good question. I wouldn't call it the sidechain circuit, but I'd call it that when the APB operates, any APB plugin, there are two signals that go down to the APB box. There's the audio, then there's like this control signal, which is like, okay, yep, it might have like a sidechain in it. It'll have other things in it too, but they are married together. So there's sample accurate control over that converted analog signal. As you go into the box, the control signal goes off and says, hey, we're doing this today. Thanks for coming. And then the signal is going through the analog components. Maybe there's clearly like, maybe there's like a setup point, like when you instantiate the plugin and we set the configurable analog up. But then after that, the control signal being married to the audio signal will just do what we want it to do. And it does it in a way that's, not just real time, but, synchronized perfectly. So you come out the other end. There's no like, oh, I missed that peak or I didn't catch that. It's all in a line.
So, what can you do with APB that you feel that you weren't able to do with a conventional digital plugin?
There was one interesting point to start with is that distortion. I know a lot of people get really excited about distortion or saturation or whatever that is. And that's great. I think it's a good part of what audio production should be. There should be some exploitation of that type of processing element. But in the APB, it's all kind of like built in. It's like, yeah, I'm an analog signal path. I can only go this loud. If you go louder than this, I'm not going to like clip digitally. I'm going to saturate with some like probably pleasing curve that some hardware engineer named Glenn fussed with for a year to say, it's going to look like this. Oh, that looks really good. Check it out in the scope. So it has some of those built-in elements. So when you're making something in it, you can kind of go, what if the user cranked up the makeup gain in the compressor? So it doesn't matter. It's going to saturate in some one of three saturation circuits calibrated perfectly to the analog to digital converter. So when they get it back into the DAW, they'll just have the analog distortion and none of the whatever digital mayhem that may have occurred. So you asked me if the differences. One difference is just that there's this saturation element of the APB circuit that's just kind of built in. Whereas in digital, you're like, I can get as loud as I want. I guess the other part would be it's like a pen, right? Some people like, I don't know, ballpoint pen. Some people like a felt tip, whatever it is. It's just that, it's different. Oh, I like this. Oh, I hate this. And so it's interesting just to take a different tool set, analog versus software, and go, well, what can we do with this? And then find strengths and weaknesses and go, well, these are the strengths. Let's see what we can do with these strengths. And then just keep pounding that idea and come up with, new compressors or different types of way to complement a digital equalizer with a custom analog output stage, just those types of things. It's fun.
At the moment, all the plugins that are available for APB are fundamentally mostly their compressors. What can and can't you do with APB? Could you, for instance, extend the concept to mic preamps or guitar amps?
Ooh, mic preamps or guitar amps, that is a possibility. I think in the current configuration of the APB, that is designed for line level inputs. So we'd have to have a bit different flavor of some kind of input circuit to do that. But don't think that we're not thinking about things just like what you said. So anyway, so there's that. But yeah, but mostly it's dynamic range control or saturation stuff, and those are sort of the wheelhouses of what the APB design that we've come up with does.
I guess one other thing that you could, in theory, do with APB that you can't do with most analog devices is beyond stereo. You could go to multi-channel compression if you wanted to. Is there any call for that? Have you explored that?
Yes, there's also this thing called Dolby Atmos. Apparently, it's kind of popular. I don't know, more channels than your brain can keep track of in a mix. But yes, there are several clients right now using the APB. They use it in their Atmos stuff because they want to have analog, but configured across many channels to do something. And apparently, it seems to fit that market well. So yeah, we actually do have some multi-channel requests.
And I guess another obvious use case for it would be mastering, because mastering engineers like analog gear, but they also like complete recall, which is what you get with APB.
Yes, there definitely is a mastering engineer interest in the product, and for exactly the reason you just said, or for most engineers in general. Oh, I can recall it? Wait, what? It's analog and it's recallable. Don't forget all the presets and automation and sample accurate control of all the analog. Yeah, right. Okay, that's those are all the problems with analog, and you solved them all. Yes, we did. Wait, what about delay compensation? Yeah, we solved that too. Oh, I can't hate this thing. God dang it. I'll have to buy 6. Fine. Yeah, recallability is huge. In fact, actually, my own personal self, just a long time ago, maybe when I played in a band or two, we'd go into the studio and all this equipment is great and we're doing our stuff. And I'd watch somebody patch in some outboard gear for a thing. Oh, those drums sound great or whatever. And then I just would panic because I'd be like, okay, the electrical engineering student in me is looking at what we've done and I see how it's kind of repeatable, but not really recallable instantly. So like if we don't finish this like today, we have today to get this done. Because if we come back tomorrow, it might not be exactly the way it is. And I'm not even sure I've kept track of everything that we've just patched together in the right order, even though I'm trying to. And that's, look, the nervous twitch is coming back. You can see. So, recallability is, that's a good point, Stan.
But I guess also, I mean, you've chosen to focus on saturation and compression and limiting with APB as it stands. There are other things that people love in analog too, analog EQ, for example, analog effects and delays. I guess, could you apply the same concept in those fields?
Yes, you could. And again, no confirming or denying what we might be tinkering with, but we'll see. On the topic of EQ, however, or delays, I'll point out these two things with the delay and EQ types of effects in the APB. First one, on the EQ, any curve that you want from any vintage equalizer, you can pretty much nail in a software model. That's not what's in question when it comes to the sound, quote unquote. It's what was the input stage, either prior to, during, or after that EQ curve has been applied to the signal. That is, that's, to me anyway, that is like where that's why it's different. It's not that I can get the, scoop of a Pultec or the shape of a parametric from whatever. It's that at some point it goes through something else. There's something else it goes through, right? An analog system that's around that equalizer that has a fixed range, that if you get up too close, it's going to not clip, it's going to saturate in some way. What is that system? And so in those ways, the APB is well configured to do that. If someone really, really, really wants to have, the op amps and the feedback loops to do the EQ stuff, yeah, you can do that, but then you get stuck into these fixed topologies where, oh, it's only going to be a parametric, or oh, it's only going to be a shelf. Then I'm like, yeah, and also you're going to use up so many op amps on one channel. If you put 8 of those together side by side, that's going to be like the sun. So I'm not sure. Still thinking about it though. And then on the delay line stuff, you have stuff like your bucket brigade, analog delay, or things like that. That's interesting. But also even just if you have a delay, and imagine what is it about the analog delay you like? Well, there's the delay time part, and that's sort of the slew of the delay time being longer or shorter. Okay, we can kind of approximate those, I think, in digital, pretty well. But again, it comes back to what is the output stage? What happens in that feedback loop? Where in that system is the part where the analog component goes, this is my jam, I'm stepping in, boom, boom, and yeah. So maybe in the feedback loop of a delay line, what if it went through analog? It'd actually be really cool. Yeah, so if I cranked up the feedback and now the delay was going, bonkers, but it kept going through an analog system as it fed back and went bonkers, that might be really cool. Not that I would know anything about the delay for the APB that would have such a circuit.
So for you, what people love about analog EQ and delays and so on is generally the analoginess pretty much all comes from saturation, and that's what you need something like the APB to do. You can actually emulate the other parts digitally and it's fine.
Yes, that's what I believe, and not everyone has to agree with me, and that's okay. I mean, I think that we're just exploring something that's kind of new and different, and it's fun, and people that like it, knock yourself out. But yes, that is my reasonably strong belief because I've invested a lot of time, money, and McDSP is self-funded, folks. Yes, so I think it's a fascinating way to apply or combine analog and digital processing, kind of a hybrid system. The configurability of the analog system we've come up with I think is really exceeded my expectations. I'm very pleased with it. We're just going to keep making more stuff.
That sounds like a good mission statement. Well, we've had a few hints then about what might be coming down the line. Any further things you can tell us about the future? What's coming?
I think that right now we're still rounding out some of the what I consider bread and butter functionality for the APB. I think we got a good pile of compressors, a couple of limiters. We have one equalizer. I'd like to add a few more of those because that first one, the Royal Q, it turned out really good. So that was very exciting to work on. And so we'd like to do a few more bread and butter tools like that. And then from there, we'll go into a little more of the exploratory, how about a delay system that has the analog feedback path and things like that. Some people have asked us about transient designers, which I don't think is unreasonable. I just haven't quite had time to experiment with that. Also, on what's coming next to the APB, maybe you've heard COVID, climate change. Also global supply chain crazy issues. So I will certainly say to anyone who asks, yes, of course we've been affected by that. Because I hoard gear, for a hobby, I've also been very good at hoarding parts for the APB. But we've been sold out since October of 2021. And we're still back ordered, but we have more on the way. So I think some people say, hey, what's the holdup? I'm like, well, when you say I want the best 32-bit, converters on the planet, well, sometimes you got to wait for them. Some developments with APB have not been as quick as I would like. And some of that I would put a little bit of blame on the global supply chain stuff, which is annoying. But also, if you haven't heard, Apple came out with a new hardware paradigm. Right about the time we shipped the APB, hey, the M1 is going to be great. Whole new hardware processor, you'll love it. Okay, so in the immediate future at McDSP, we'll be releasing native M1 support for the APB plugins, which is, I think, kind of cool and was some work. And then after that, I think we'll get back into the wheelhouse of making more APB plugins that will round out the feature set of what I think should be delivered with a purchase of an APB unit.
Awesome. Well, if you've put down your deposit and you're waiting for an APB to arrive, I can promise you it's worth the wait. It really is a stunning achievement.
Thanks, Sam.
Meantime, thanks very much to our guest today, Colin McDowell.
Thanks for having me.
You've been listening to the Sound on Sound People and Music Industry podcast with me, Sam Inglis. Thank you for listening, and be sure to check out the show notes page for this episode, where you'll find further information along with web links and details of all the other episodes. And just before you go, let me point you to the soundonsound.com/podcasts website page, where you can explore what's playing on our other channels.